Good morning, everyone out there in YouTube land. My name is Jared, and this is my channel, Mazda B3K. In this episode, I'm going to show you how to do troubleshooting on your entire glow plug system, not just the relay, but the plugs, the wires, the whole 9 yards. Without further ado, let's get started. Okay, folks, so where we left this, in a previous episode, I replaced all 8 of the glow plugs, which are those little dudes there, with official Motorcraft ZD9 glow plugs. I did that, and I thought my glow situation would be perfect, life will be grand. Roll the key, constant clicking, glow relay won't stay closed, and I got to figure out why, because this truck likes its glow. If it's a cold day and you don't have glow, you're going to roll the starter a long time before it finally goes, and you put a lot of stress on your starting system doing that. So got to figure out what's going on. I'm going to show you the troubleshooting I have done so far. If you have a test light, if you have a multimeter, you can do quite a bit of troubleshooting as per Ford's official diagnostics before you have to start throwing parts at anything. So let's get into that. All right, first things first, to do any meaningful work on the glow system, hat's got to come off. Mine, I didn't put the bolt back in because I've been working on this for a couple days now. So there's a bolt, it's probably 9/16. It may even be a wing nut if you've got the original. And just take it off. Put it down somewhere. Don't lose the bits. See, I've got this now. What came with the truck. So that's step one. All right, now we can actually begin. So to follow Ford's troubleshooting, this is what we're gonna do. The very first thing you're supposed to do is check the glow plugs. Check them on the vehicle. And to do that, Ford wants you to take all your wires off, okay? So take off all 8. That's off. All right. That one's off. That one's off. 1, 2, 3, and 4. Okay, so that's step 1. Step 2 is you're going to need a test light. Now, you can do this without a test light, but a test light does make it a little easier to do. So let's go grab that. So you're gonna take the test light. You're gonna hook it to positive on the battery. Doesn't matter which one. Either is good. This is a diesel, so it's got 2. And then what we're gonna do is I'm gonna take my little safety cap off the test light, put it somewhere so it doesn't get lost. And what we need to do is we're gonna touch the tip to the top of the glow plug. Now, if you've got an old school test light that actually lights up, then you should see it light up. If it lights up, the glow plug's good. In my case, I get a screen that lights up and I get a voltage reading. And I should be seeing a voltage that's pretty similar to the voltage of the battery right now. So let's actually check that real quick so we know what we're looking for. All right, so got this on. Let's hook the positive in there. Let's hook our negative. So currently we're right at 13 volts. Now that should drop down to around 12.9. These batteries are fully charged. That's a little surface charge because I just took the trickle charger off. But so like 12.9, 13, that's what we're looking for. That's what we should see on my test light when we do the test light thing. So tearing our multimeter off. And then we're gonna come over here. And so here's our glow plug, right? We're gonna touch. I'm gonna spin this around so you can see it. We're gonna touch the top of it. What do we see? We see 13.1 volts. This glow plug is good. So we come to our next one. And we touch the top of it. It's kind of tricky to touch the top here, but let me spin this so you can see it. Daggum. 13.1. So it's good. So check all 8 in this manner. And if, like I said, if you're old school and you just have a bulb, if you see one where the light doesn't turn on, or it struggles to turn on, or it's dim, you've got a bad glow plug. And you should change out all 8, because assuming that all 8 were installed at the same time, if you've got one going out, the others are not going to be far behind. And also, with the way that the glow relay works, if there's even one plug that's not working quite right, it'll pitch a fit and not work. And by the way, spoiler alert, this is what your glow relay looks like. It's electromechanical. It's got a little logic board at the bottom. It's got a relay similar to a starter relay right here, and it has a shunt to give a specific resistance, and it's looking for a specific resistance off of the glow plugs to tell it whether or not it needs to turn on and heat them up. So essentially, it's using the resistance rating of the glow plug to figure out if the engine is hot or cold. So as glow plugs go bad and the resistance gets abnormally high, it thinks the engine's already hot when it's not. So then they don't run. And there you go. So I'll finish checking all 8 of my plugs, make sure they're good. They should be good. As you can see, here's the original 8. You can also do resistance testing on the plug. Take it out, or you can also test it in the vehicle, but it's a little trickier because your block can be dirty. But of these 8, only one of them was working. Only one of them came back with a resistance that wasn't in mega ohms. So I had 7 bad, 1 good. That's why I thought, yes, this will be perfect. It'll work. Spoiler, it did not work. Let me go test those other 6. I'll get back with you. Okay, all of my plugs came back as 13.1 volts, which is what I expect. It's a brand new set of Motorcraft's ZD9 plugs that I also did resistance checks on before I installed them in the block. And they all came back good. So the way that you would do this with a multimeter is set your multimeter to volts, should be. And you're going to have your positive lead on a positive terminal. Take your ground, and you should be able to touch it to stretching. You should be able to touch it to, I know it's a little ridiculous there, to your glow plug, and you get 13 volts. So test light's really convenient. It's a little bit less hard to use, but as you can see, you can also do it with a multimeter. We have 13 volts. It's grounding against the radiator. That's funny. Anyway, basically you're checking to make sure the plugs have good ground contact with the block. That's the whole point of that. Because the tip of the glow plug is not touching the block or the engine. So the idea is that it grounds against the threads of the plug. So I know I'm kind of getting off track here, but for those who are nerding out about this, you're touching the tip here. The plug doesn't ground out until you see the threads and it's screwing in, and that's how it touches the block. And then you've got ground cables that go from the block back to the battery, and that's how it completes the loop, and it grounds out. So the idea is, if you touch this tip, you see 13 volts, that means that there's basically no resistance through this plug. Because if the plug is bad and there's high resistance through here because the element's busted, you're not going to see 13 volts because you won't have a ground. And it's not going to work. Electricity needs a loop. So that's how that test works, in case you were curious. All right, next step. Okay, next step. We need to test the continuity of our harness. So in my case, someone has already replaced this harness once with a kind of poopy reman kit. I'm not impressed with this. But next step is check continuity, which means we want to make sure there are no broken wires, right? So all 8 of these glow wires come back to that guy. See that lug? It's super fuzzy because my camera won't focus. See how it's got the big shrink sleeve and it has 2 red wires coming out the back? That goes out to your 8 glow plugs. So what you have to do is you set your meter to ohms. You put 1 probe on this lug, and then you're going to put the other probe inside of your little connector hat here, and then you're going to see the continuity. You should see something around 0.5 ohms. If you see anything that is drastically bigger than that, you probably have a continuity issue. You have a bad connection somewhere. All right, for purposes of showing you guys this, I don't have enough hands nor a tripod that's going to fit, but I do have a fancy meter here, and you see how it's got that kind of Doppler sign? That means it's going to squeal when continuity is achieved, right? So what I'm doing here is I'm going to set the phone down that I'm recording with, and you guys, you should be able to hear it squeal when I get this to connect, because I don't have the hands. All right, got you guys on a tripod so we can make this work. So we're going to take 1 wire goes in the hat, other wire goes to our lug, and we're squealing, and we have 0.3 ohms. Huh, that was still making a ground somewhere. Okay, so you're going to repeat that process for all 8 wires. Now, an additional thing that you can do that I did already is you connect your wire back, and then you check. We put 1 probe against the glow plug and then the other probe on that lug I showed you. And what that does is shows you that you have a good connection to your glow plug with your wire, right? If you're at 0.5 ohms or less, it means that you don't have a loose connection in your little snap cap. Because that's what's supposed to do, is these are supposed to have like a positive enforcement to let you know you've got the wire on correctly. And at least with mine, they didn't choose a good kit, so it doesn't give you that nice feel-good click when you push the connection back on the hat. So like I said, you can take 1 probe, put it on your glow plug, take the other probe, put it down on the lug, turn your meter back on, function, and we get 0.6 ohms. So you can do that again with all 8 of your wires, and then okie dokie, you've got continuity. Okay, next thing we got to check, we've gone through our plugs, we've gone through our wires, and assuming your wires are fine and your plugs are fine, now we got to start taking a look at the glow controller and the relay. So the next step is we need to make sure that the logic board, which is in that black base, has a proper ground, because it's a little bit of smarts, it's a little bit of electronics, and if it doesn't have a good ground, it ain't gonna work right. So over here, buried in here, let's see if I can get you to it. Right there. Oh, you guys can't see that. There we go. You should be able to see that. That's the ground. Right there. So that wire goes from the logic board, as you can see, and it goes to a should be a connection kind of back here. I may not be able to show you, but it's going to go to a screw on the block somewhere back here. And that is your ground. So we need to check, we need to take our meter and put one probe there, and then the other probe against the negative of both batteries. We need to make sure it is grounded out against both sets of batteries, because I'm assuming because you got glow plugs on either side of the engine kind of thing. So I'm going to put you back in the stand. We're going to test this. Again, I'll set my meter so that it makes noise so you guys can hear, and I'll read out what the meter shows. All right, we're going to test against the driver's battery first. So let's do function. Let's make it noisy. Let's do our continuity check. So we're going to put one end negative terminal on the battery. The other end goes to our ground. And we're getting 0.8 ohms is what I'm seeing. And you have to touch it against the eyelet, not the screw, okay? We're getting 0.8 ohms. All right, so now, sorry guys, you probably just saw my ear. Move the ground over to our passenger battery. Try to avoid the injection pump, and we check it again. And I get 0.7 ohms, 0.6. So that's a good ground. All right, so we've shown that the logic board is grounded out. This is good. All right, here you go. Okay, so this logic board is grounded out. Bad. That is good. Board. Next thing we got to check is, but he had left it in there. That's why. Are we getting power? Anyway, so this lug here is where. Let me take you over to the bench, and I can show you what's there better than I can show you. Hot at all times, where it actually comes in off the starter solenoid. So what we're going to do is we're going to put one probe here, and then our other probe is going to go here, because this is where that ground is tied in, and we want to see battery voltage. So we want to see around 13 volts when we check voltage between here and here, and that will ensure that yes, we're getting power. Now in my case, I already know I'm getting power because I can hear the glow relay trying to close. It just won't stay closed. Mine's been worked on, but these two big blue wires that come back to these two black with orange, which in turn they go into some, should be buried in here. There should be some fusible links they go into. Oh, they're over here. But you can see wired onto the hot side, the hot at all times side of the starter solenoid. That's the power for the glow relay. That's what we're checking. So let's go ahead and check it. Okay, it looks like you guys can actually see the meter as long as I don't move it. So I will leave the meter where it is. And let's test this. If I can get the wires untangled. All right, so we're gonna put our positive there. Contact our ground here. And hopefully that says 13 or something close to it. I cannot see it from the angle on that. Well, it also would help if I actually set it to voltage. That would be nice. All right, I'm seeing very vaguely 13 volts, so we're getting power. That's not the problem. Okay. So we know we have power, but we're dealing with a relay. So it's not enough that our big power is coming in. We also need to check to see if our signal power is coming in. What do I mean by that? let's go back to the bench, talk about that. Okay, so on our IDIs, we know that the glow relay is supposed to come on when we turn the key to the run position, right? How does it do that? Well, it does that because it's a relay. And very, very simply, what relays do is they've got a coil, and when you energize the coil with small power, it's magnetic, and then the magnet does magnet things, and it closes a switch, which then allows big power to flow through. So on this relay, the big power comes in here. We just tested that. And when the switch closes, it's supposed to go through here, come down through this shunt, and then it goes to here, and this is where your glow harness comes in, right? But we got to get the small power to work first. We got to make sure that's okay, otherwise big power never gets turned on. So your small power comes in here. This is from your ignition switch, right? When you put the key in, you roll it. So what we're going to do is we're going to roll the key, and you're going to kind of know this because it's going to start clicking, and then we can take the meter, and again we're going to take one probe, our positive probe, put it here, and then the negative probe is going to go against the ground that's right here. And again, we're looking for something around 12 to 13 volts. If we're seeing that, then we're getting our signal in from the key to tell it to go ahead and close so that big power can go through. And what this is right here, this is an additional ground on small power that allows the logic board to control turning the glow relay on and off, the big switch right here. So let's go ahead and test the small stuff. Okay, I brought you back after it finished making its attempts because it's really obnoxious to listen to, but also the glow relay pulls like 200 amps when it tries to go. So we're probably not going to see 13 volts anymore. It's probably going to be something like 12.9, 12.8, something along those lines. So let's see what we get. If we go against our signal and our ground, and I can see something like 11 point something volts. Is that like 11.8? And for that signal wire, that's fine. Which means, okay, we're getting signal from the key. This is good. Okay, at this point, let's recap. We tested our plugs. Your plugs were okay, you moved on to the next step. You tested the harness. If the harness was okay, you moved on to the next step. You made sure the ground for the logic board was okay. If the ground for the logic board was okay, you moved on to the next step. You made sure that our big power coming in was good. You tested here. If that was good, you moved on to the next step. You tested to see if our small power, our signal power coming in from the key was good. And if that was good, you moved on to the next step, which brings you here to where we are now. Next step is we're going to replace this relay because we've tested everything coming to the relay. We've tested our glow plugs to make sure their resistance is good. We've tested our harness to make sure its resistance is good. We did all those continuity checks and all that jazz. So now we're at the point where we need to switch out this relay. Now, the Motorcraft relay is something like $60 and it's getting hard to find. Standard and a couple others make a relay that works, but you have to do a little extra work to make it work properly. All right, this is a SMP or a standard RY175. Now, the big thing here is this is a 200 amp relay. It can handle the energy that the glow plugs want to make stuff happen, which is good. But unlike the original Motorcraft relay, it does not pull its ground from the same ground as our logic board. See, a logic board has lots of wires. One of those is the ground. It does not pull it from there. So what we're going to have to do is when we mount this guy back up, we're going to have to run a ground from here or here and then tie it in to ground that's on the block somewhere so that the relay itself is grounded so it can do the job it needs to do. But this one can handle the energy. We got big power to big power, small power, small power. And at least if you buy the standard one, even comes with a little bit of hardware so you can put everything in. So our next step now is I'm gonna disconnect the batteries because I'm gonna have to take this entire assembly out so then I can take the glow relay out, move everything over, and then reinstall and test. All right, here we are. This is the relay and controller that, oh, there's moisture there. That's not necessarily good. But this is the one that came out. So now that this is out, we can go ahead and work on removing the rest of this. I will get a diagram, or you should take a picture before you take this out so you know what goes where. I have a diagram so I know what goes where. And yeah, so I'm going to go ahead and get this swapped out. Ooh, that looks like that was getting hot. Yeah, look at that. That, or they just carved a hole with a nut. One of the two. Anyway, let me get this swapped and I'll bring you back. Okay, here's what we look like with everything disconnected. We're getting ready to put new stuff in. So our new relay is gonna go in like this, right? But like I said, we're gonna run a ground from here, and it's gonna wind up double stacking here on top of this one. So you're gonna need to either purchase a wire like that or make one. I've got the tools to make one, so I'm gonna go ahead and do that. And then I'll just start putting it all back together. All right, guys. So everything is back together with the new relay in. Notice there's another ground there now. I ran that ground from, might be hard to see, but I ran it from that eyelet right there, or that bolt. And then I ran that over to here. So now the relay itself is independently grounded from the controller, the actual logic board. Also, make sure you go through, and if you have not done it, reconnect all 8 of your glow plugs, because remember, this works on resistance. If the resistance value is not what it's expecting, it just starts clicking madly, and you don't learn anything. If you've done all of that, you've checked all your connections, everything looks good and clean and tight, good job. Now, come back, reconnect your batteries, get those tightened up, then we'll roll the key and see what we get. Okay, everything's back together. Let's roll the key, see what happens. No change. So this comes back to either it's not happy with the resistance reading that it's seeing from my brand new known good glow plugs, or the logic board has given up the ghost. So I have, as I've shown you, I have this old logic board. They rarely go bad. They do, sometimes go bad. So I'm going to try moving this relay over to that board. That's the last thing I'm going to try. And if that doesn't resolve the issue, I am not paying $100, or maybe I will pay $100, depending on how much of a sadist I am. And I'm either going to move to a manual glow system that just cuts all that stupid out with a switch, properly wired, of course, or get the new one. But it's kind of frustrating. Good news is the new relay is working. The ground I ran worked. So rip it all back out and try it again. All right, let's roll the key, see what we get. Oh. 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 I think we had a bad logic board. Or the relay never closed in the first place. One of the two. Gonna have to dig into that. But it's not clicking like a madman right now. Alright guys, many hours later, this is what happened. I swapped the relay, continue to get click, 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 click. So I did a couple different things. Like I said, I swapped that other supposedly junk controller in. Indeed, it was junk. As you guys saw, nothing happened. Just a logic board totally fried. So then I did a whole bunch of testing and combinations of with a ground wire, without a ground wire. There's all sorts of silliness. And I couldn't get anything but click, click, click. So I went to the store, bought a brand new controller. I'm gonna show it to you. When you buy a brand new controller, oh, it must be in the truck, but you get everything. You get the relay, you get the logic box, you get everything. It's ready to go. All you have to do is install it in your truck. That's it. So I did that, installed it in the truck, and click, 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 click. So in my application, in my case, after testing everything I could test and finding everything to be good, I determined that, quite simply, the Glow controller is just stupid. And there was something it still didn't like. I didn't know what. A resistance value it didn't like. Don't know where. So I have converted this over to manual. I have gotten a momentary switch, and I have converted this to a manual. That is now working. Give it 5 seconds of glow, the truck immediately fired up. That was a pain. I still got to clean everything up, but basically, to go manual, the white wire, the one that you're not supposed to touch, you know, because lightning bolts will strike you from the heavens, you remove that, and then hide the end so it can't touch anything. That's step number one. Step number two is you take that connector there, which is for your waiting to start light, and you're going to cut it off on the controller side. You see that splice right there? And then you're gonna, I don't know, I was following a guide. The guide said 12 inches, 1 foot. That's way too much wire, as you can see. But you splice that, and then you're going to connect it on the same lug where that white wire used to go. Then you're gonna take the positive side of your switch, which is the red wire you see, and it also gets connected to that lug. And then, as you can see, I've got the wire running over and around. And what I did is I borrowed the grommet for the trailer brake balance controller. Borrowed that grommet, blasted a hole in it, shoved a wire through it. And then here in the truck, it's not cleaned up yet, obviously, but I've got it in on my momentary switch. This is a starter momentary switch, so it's a little beefier. I figured since this was a glow plug application, 200 amps and all that jazz, beefy was good. And then I have a ground tied into an official ground point. Let's see if I can get it, show you guys. You should be able to see it. I can't see if you can see it, but there's an official ground point right there. So I tied to that, and I just tested it. And now what happens, let's get some light up here. When I roll the key, this is what you get, right? So you don't get clicks, you don't get doodly squat. It's just quiet. So then you grab your switch if you look at the wait to start, when you push the switch, it turns on. And did you hear the click? The relay is working. You can hear it clicking. So we're finally in a situation where I have glow. It's working. It's manually controlled. I'm going to make a hole, and the switch is going to be wind up being mounted kind of up in here. That's what I've got room to do with the wire that I have. I mean, you know what? Actually, I could mount it like, well, maybe like right there. Make it come in low, below the fuel selector. I could do that too. Maybe you know what? I think I'm going to do that, because I can take, or if I can make it reach, which I think I can. Yeah, I have to tack it up, but I think I'll put it actually right here, because I can pop this panel off and make it real easy to get this mounted. Put it back on. The point is, we're good. Finally, the guide I laid out today is good. It is from Ford, the step-by-step procedure of what you're supposed to do to test every part of your glow system. So if you're having problems, check it out. Normally you just got bad glow plugs, but it could be more. Yeah, I hope you don't have near as much trouble as I did and have to resort to a off-the-shelf application here like I did to make it work. So that's it for this video. I'm filming the outro. Good morning, everyone. Today is a new day. I apologize for the lighting. I don't have any of the interior light fixed in this truck yet, and the sun has yet to rise. But now that I've got my manual glow set up and everything, I wanted to see how this truck would react with a true cold start, as cold as I can get anyway here in the south. It's about 29 degrees out right now. I don't expect this to be perfect, because I've got some leaks in my return system, but let's see what this does on 10 seconds of glow. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pedal down and crank. Now that is a result. Alrighty folks, that's going to do it for this episode, where we did troubleshooting of the glow system in my 1989 Ford F350 7.3 liter IDI diesel named Bertha. And we also covered how to do a manual bypass, and showed a successful test of the glow system by cranking in 29-degree weather. If you found this video interesting, if you found it entertaining, if you learned something, please consider like, share, and subscribing. That does help to grow the channel, which allows me to bring you more content like this. Please also leave a comment. I like to read them, I like to reply to them, and I like to learn from them. Lastly, guys, I make mistakes, so you don't have to. I'll catch you guys next episode.